Nice to meet you. I'm Khatar Choktai and you're watching my YouTube channel, School of Advanced Chemistry. I'm going to explain period 3 element reactions, observations, and equation. Reaction of period 3 element with oxygen, with water, with chlorine. Reaction of period 3 element oxides with water and with acid. And the reaction of period 3 element chlorides with water. I'm going to revise you all these reactions very quickly. Let's jump into it. All period 3 elements interact directly and exothermically with oxygen and with chlorine, except argon and chlorine itself. However, in order to overcome the energy barrier for this reaction, they frequently require significant initial heating. So heating is the essential condition for these sort of reactions. The flame color of sodium is yellow, that of magnesium and phosphorus is bright white, and of sulfur is blue. Only magnesium and sodium produce flame when chlorine is allowed to react with these elements. This indicates that the reactions are slightly less vigorous. Now let's talk about the reaction of these elements with oxygen, with chlorine, with water, and so on. Period 3 elements basically show 5 types of chemical properties. Number 1, they react with oxygen directly, they react with chlorine directly, and 2 elements, sodium and magnesium, react with water directly. The next thing is their oxides react with water, react with acid, and so on. Their chlorides, they also react with water. So generally speaking, overall speaking, there are basically 5 major main type of reactions over here. Now, reaction with oxygen. Number 1, with oxygen. So sodium react with oxygen vigorously, and it's supposed to make Na2O, sodium oxide is formed. And for the sake of balancing equation, I'm going to put 2 over here and half over here. Sodium oxide solid is supposed to be formed. Sodium is solid, oxygen is a gas, so these are the state symbol. In case of magnesium, when magnesium is allowed to exposed into the air, then there is no such a noticeable observation. Yes, MgO, a coating of Mg oxide, MgO is formed. The coating of magnesium oxide is formed, but this reaction is giving no any sort of observation. There is no any appreciable observation in this case. But when magnesium is going to heat with oxygen, so if I'm going to heat this reaction, this magnesium ribbon in the presence of oxygen, then yes, it burns with a bright white light flame and there is the formation of MgO. So in case of heating, magnesium burns vigorously with bright white flame, The next reaction is aluminium. When aluminium is allowed to react with oxygen, definitely we will have to supply heat. The basic condition is heat. Then there is a formation of Al2O3. Al2O3 solid. As you have seen that sodium oxide is solid. MgO, magnesium oxide is solid. Al2O3, aluminum oxide is also a solid. Next one reaction is silicon. When silicon is heated strongly, here we need strong heat. So it's supposed to make SiO2. Again, it's a solid at room temperature. Next element is phosphorus. If phosphorus, let's suppose P4, it's a solid, as silicon is also solid. Gas, solid, gas, and so on. These are the state symbols. When phosphorus is allowed to react with limited supply of oxygen, let's suppose with 3 mole of oxygen, then it is going to make P4O 6 in case of limited oxygen. If phosphorus is allowed to react with oxygen in plentiful supply of oxygen, let's suppose here it's going to react with 5 mole of oxygen, then it will make P4, similarly P4, but this time there is O10. So they both are having different oxidation states over here. Next element is sulfur. When sulfur is allowed to react with oxygen, first it is going to make SO2, sulfur dioxide. And furthermore, if you are going to use plentiful oxygen, I mean, in case of excess oxygen, it may be changed into SO3, but this reaction is reversible. I mean, there is no enough yield of SO3 without using any catalyst, without using any pressure and temperature and so on. Now, we can see that here is a change in oxidation state of each and every element in the compound. Sodium is showing +1 oxidation state. Magnesium is showing +2 oxidation state. Aluminium is showing +3 oxidation state. Silicon is showing +4 oxidation state. In this case, phosphorus is showing +3 oxidation state, and here it's showing +5 oxidation state, and it's showing +4, and here +6. So generally, we can see that they are showing their oxidation numbers, oxidation state with respect to their last shell electron. So the maximum oxidation states are over here. These numbers are according to their valence electron. So these are basically reaction of period 3 element with oxygen. The next thing is SO2, sulfur dioxide is a gas at a room temperature, but SO3 is low melting point solid. P4O10 sublime when heated. I mean, it's a solid. When it is heated, it's sublime. It change into the gaseous form on heating. So it shows sublimation. There is no melting of P4O10 over here. The next thing is Al2Cl6 is a dimer that again readily sublime on heating. If we are going to heat it further, I mean, let's suppose it is in form of vapors already, that is in form of vapor. If I'm going to heat it further, and it will change into AlCl3, 2 mole of AlCl3. So the dimer break down in aluminium chloride into aluminium chloride. SiCl4 is a liquid basically at room temperature, and PCl5, it decomposes when heated. There is a decomposition or thermal decomposition to give PCl3, that is a liquid, plus Cl2 gas is formed. So on heating PCl5, that is a white solid basically, and it is going to decompose. Again, I mean, I'm going to put state symbol over here. These are the solids, gas, sulfur is solid, oxygen, as you know, it's a gas. So here, these are the basic main points and the reaction of period 3 element with oxygen. Now come toward the reaction with chlorine, with Cl2. Number 1, sodium, it react with Cl2. Again, vigorous reaction is over here to make NaCl, solid, and this is a solid, gaseous, and it's solid. Magnesium also react with chlorine vigorously, and it's going to make MgCl2. It's solid, it's gas, and magnesium is solid. Aluminium also burns when it is strongly heated, or when it is heated, I mean in the presence of excess Cl2, then it's going to make basically a dimer, that is Al2Cl6, that is initially solid, but it can be vaporized, it can be changed into, I mean, it can be sublime, it can be changed into gaseous state. The next one, silicon, again, it's strongly heated. I mean, heat is the essential conditions in all these sort of reactions. Here we heat strongly silicon plus chlorine to give SiCl4, that is the liquid. Phosphorus P4, it react with chlorine. In case of limited chlorine, it's going to make PCl3, and PCl3 is a liquid at room temperature. So for the sake of balancing, I'm going to put 4 over here and 6 over here. In case of excess chlorine, P4 solid is going to react with excess chlorine. So this time it's going to make PCl5, that is basically a solid, white solid. In this case, 10 mole of Cl2 have been used. So these are the reaction of period 3 element with chlorine. Again, you can see that the oxidation number is +1, +2, in this case +3, +4, and +3, and maximum of phosphorus is +5. So again, the oxidation state of the element with chlorine is changing according to their, generally according to their valence electron. I mean, they are showing their maximum oxidation state, and that is the positive oxidation state. Now the next reaction is reaction of element with water. Sodium react with water. The reaction is quite vigorous. It's going to make sodium hydroxide aqueous. It catches fire and it float randomly on the surface, float on surface of water. And hydrogen gas is formed. In this case, basically sodium hydroxide and alkaline solution is also formed. When magnesium is allowed to react with H2O, here H2O is liquid, is solid, it's aqueous, and plus H2, hydrogen gas. Magnesium plus H2O, in case of cold water, liquid being it's a cold water, so the reaction is too slow to observe. Reaction is too slow to observe. There is almost, you can say, no reaction, or there is very slow reaction. Only one test tube of the hydrogen can be filled after several hours. Generally, here is the formation of magnesium hydroxide plus hydrogen gas is formed. Magnesium hydroxide, you can put aqueous over here. It's slightly soluble in water, and hydrogen gas is formed. It's a solid. Now, the next thing is whenever the magnesium is allowed to react with the cold water, then it's going to make hydroxide. But magnesium react vigorously with the steam. Steam mean water in form of a gas, that is the, I mean, a representation of steam, and it's react with, obviously we are going to heat it over here, and it's going to react vigorously with the steam, and this time it's not going to make magnesium hydroxide, it's going to make magnesium oxide. You can write aqueous or solid, and hydrogen gas is over here. In first case, we will have to put 2 over here, and over here there is no need to put 2. I mean, here is the 1. So this is the balance equation. Only 2 elements, sodium and magnesium, are supposed to react with water. None of the other period 3 element is going to react with water. Now, the reaction of oxides, reaction of oxides with water. For example, the first one oxide is Na2O. It's a highly soluble oxide. It reacts with water. Again, it's going to make sodium hydroxide. So 2 mole of NaOH aqueous is supposed to be formed. It's a solid, water is a liquid, and it is going to react with the water to make 2 mole of sodium hydroxide. Next thing is the pH of this solution is supposed to be 13 to 14 as it is a strong alkali. Next reaction with water is of P4O10, SO2, SO3, and so on. So only this metal oxide give an appreciable reaction with water. Now the next reaction is P4O10. P4O10 is a solid and it's going to react with H2O, water, to make H3PO4, that is basically said to be phosphoric acid. So 4 over here, 6 over here, and this is the balanced chemical equation. Next one is SO2. It's going to react with water to make sulfurous acid to make H2SO3, and it's a balanced equation. It's a gas, it's a liquid, and these are the aqueous acids. Then SO3 can also react with water, and obviously this is a vigorous reaction once again, and H2O is a liquid and it is going to make H2SO4, sulfuric acid this time, and these are the basic reaction of oxide of period 3 element with water. Now the reaction of oxide with acid. Oxide plus acid. Period 3 oxide, especially first period 2 oxides. I mean, sodium oxide, Na2O, and MgO. These both are said to be basic oxide. They both react with any acid like HCl to make salt and water. NaCl plus H2O. So aqueous, solid, solid, and it is aqueous. In this case, I'm going to put 2 over here for the balancing of sodium, so 2 over here. In case of MgO, it is also quite capable to react with HCl to make MgCl2. It's aqueous, and yes, H2O, I mean liquid, is supposed to be formed. So these two oxides are basically basic oxide. Now the next oxide, especially aluminium oxide, Al2O3, is said to be an amphoteric oxide. What is amphoteric oxide? Amphoteric oxide is an oxide that reacts with acid and it also reacts with the base. I mean, it can neutralize the acid as well as the bases, so it is said to be or known as amphoteric oxide. So the reaction of Al2O3 with acid and Al2O3 with base. First of all, I'm going to react Al2O3 with acid. So plus, let's suppose H positive ion, so it will make Al2O3 plus H positive ion goes to 2 mole of aluminium 3 positive ion aqueous plus 3H2O. This is a simple reaction. I mean, if I'm going to use a complete equation, Al2O3 plus HCl once again, so it will make 2 aluminium chloride, 2 mole of AlCl3 aqueous, plus it will make 3 mole of H2O. So I'm putting 3 over here. No, I'm putting 6 over here. I'm putting 6 over here. So in this case, it is going to act as a base, and this one is going to act as an acid. Now, the next step, the next thing, the next reaction of Al2O3 when it is supposed to react with an alkali. So reaction of Al2O3 with an alkali, what is this reaction? Let's see over here. Al2O3 plus OH negative ion It is going to react, this time it is going to act as an acid, and it is going to react as a base or alkali. And here is a formation of AlOH4 negative ion. So this aluminium is the part of the negative ion. This is a unique property of the aluminium that is going to behave as an amphoteric, number one. Number two, it's the part of this negative ion. It's making an ion. So once again, if I'm going to use Al2O3 with the proper base, the formula of NaOH, then what will be the appropriate thing that is being formed over here? It will be sodium, aluminum, OH4, and boom. So how to make this equation balanced? Put 2 over here, put 2 over here. So, and we will have to add H2O, water as well, for the sake of balancing the equation. So in this case, basically, so with the help of water, we can balance this chemical equation. So this is the balanced equation that is showing the reaction of Al2O3 with NaOH. So it means that this Al2O3 is going to act as an acid, and this is an alkali or base, and here is the compound that is being formed as a result of this neutralization reaction. Rest of the all oxide are basically, so acidic oxide doesn't react with the acid. Rest of the all oxide are acidic oxide, and acidic oxide does not react with the acid. Now the reaction of period 3 chlorides with water. So first of all, sodium chloride, NaCl, it's a solid. When it is dissolved into the water, yes, it is soluble in water, and it is supposed to make Na positive aqueous and Cl negative ion aqueous. But there is no further chemical reaction with water, so it just dissolves. The next one is MgCl2. MgCl2 solid is basically, when it is dissolved in water in aqueous, it's going to react with aqueous to make, first of all, magnesium 2 positive ion plus 2 mole of Cl negative ion aqueous. Initially this reaction is happening, again this is the first stage, and it is said to be dissolution. Just dissolve, and in first step. In next step, this magnesium aqueous 2 positive ion, magnesium aqueous 2 positive ion, it is basically, that is equal to magnesium H2O6 2 positive. So this is a complex ion basically, and it further react with the water. This complex ion react with the water, and it loses hydrogen from this ligand water. So in this case, this magnesium hydroxide is going to produce H positive ion. Further, it is going to dissociate into the water. It's making H3O positive ion or H positive ion. For example, the reaction will be, in this case, MgOH, H2O remaining 5, and here H3O positive ion, and so it is making the water slightly acidic. That's why the pH of MgCl2, the pH of its solution is equal to 6.5. That is a fixed answer as far as my opinion is concerned. Whenever they're asking to write the answer of pH of MgCl2, you will just put 6.5 pH. Now the next one is AlCl3. It's a covalent molecule, and whenever the covalent molecules are allowed to react with water, yes, they dissolve, it's true. Number two, they react chemically with water. They dissolve and they also react with water as well. And this process, this mechanism is said to be hydrolysis. So this is the property of simple covalent molecule. As it's a simple covalent molecule, PCl5 is a simple covalent molecule, SOCl2, PCl5, SSCl4. These all are simple covalent molecule. they get hydrolysis when they are allowed to react with water. So this is the only property of simple covalent molecule. When they are dissolved into the water, they basically react with water and they give a new compound. So number one, they dissolve. Yes, it is true. Number two, they react chemically with water. Yes, it is true because they are simple covalent molecule. So simple covalent compounds or molecule. They are showing hydrolysis with water. So this is a unique property of a simple covalent compound. I mean, this property is a gesture of simple covalent compound only. It's showing whenever you are going to add a compound into the water and it is going to be hydrolyzed, so it means that it is a simple covalent compound. So aluminium chloride react with H2O and it dissolve and react as well. So AlCl3 plus H2O goes to, again it's going to make a complex sign, AlH2O6, and here is the square bracket, and here is 3 positive ion plus 3 Cl negative ion aqueous is going to form in first step. Now in a second step, however, this reaction is once again a reversible reaction, as this reaction is also a reversible reaction. In next step, this complex is losing H positive ion into the water, and that's why it is going to make Cl negative ion and plentiful supply of H positive ion. So I mean, misty fumes are supposed to be formed. What is happening in next step? AlH2O6 is having the complex structure. It's a complex molecule and it's losing H positive ion turn by turn. Aluminium, H2O, 5, 1 OH inside the bracket, 2 positive charge and H positive ion. You can write over here. So because of these H positive ion and Cl negative ion, misty fume or white fumes are going to be formed when AlCl3 is allowed to react with water. And same is the case, it can lose all other hydrogen from the water, as it is losing hydrogen from this water. This is the first loss of hydrogen ion. Similarly, there is second loss of hydrogen ion, there is third loss of hydrogen ion, till there is aluminium hydroxide remaining in the beaker. So in this way, this complex is acidic complex and its pH is basically written as 2. It's an acidic. You can put 2 to 3 its pH. And this reaction can also be summarized as when AlCl3 is allowed to react with small quantity of water. In case of small amount of water, it's going to react with water to make 6 HCl and 6 mole of HCl, and Al2O3 is formed in case of small quantity of water. So again, here is the formation of HCl, and these are said to be steamy fume or misty fume. So these are called steamy fume. So observation is steamy fume. The next one is SiCl4. It's also a simple covalent molecule. When water is added into this compound, into this sample, this react with water vigorously and making SiO2, that is insoluble solid, plus again HCl gas is supposed to be formed. HCl, 4 mole of HCl is supposed to be formed, and again this is the basically a vigorous reaction, and this is called hydrolysis. So hydrolysis, and same is the case hydrolysis in case of PCl5 and PCl3. In these both cases, PCl5 can react with water. Again, this is a vigorous reaction, and there is the formation of H3PO4, phosphoric acid, aqueous, plus HCl aqueous. And for the sake of balancing, put 5 over here and 4 over here. So this is the balanced equation. So these all three are the basic main examples of hydrolysis. Now, what are their basic pH? What are the appropriate pH of these samples? Basically, let's see over here. I'm going to tell you the basic pH. The basic pH. So, in case of over here, in first case, in case of sodium chloride, the pH is equal to 7. It is going to dissolve into the water itself, but it's not going to react with, water. In this case, the pH is equal to 6.5. This is the specific case of MgCl2. MgCl2. In case of AlCl3, you will write the pH. pH is equal to maybe 3 to 4. Its pH may be 3 to 4. In case of these SiCl4 and this PCl5, for these both cases, you can write pH from 1 to 2. That is the range of the pH. So these are the basic reactions, general equations, reactions, main observation of period 3 elements and its compound with water, with acid, and so on. That's all about today. Thank you very much. Please subscribe my channel, hit the bell icon, and share it with your friends. Thank you. Thank you very much. Have a nice day.